We're going to go straight into the third part of this January 2020 Physics Paper 1, which also is the physics for the Double Awards IGCSE. So if you're doing Double Award, this is the only paper you take. And if you're doing physics, you'll also get a paper 2P, I think it's called. Okay, so we've done 2 videos already. The first one was 16 minutes. Second one was about 36 minutes, and now we're going to do the third one, which is questions 8 to 11. Remember, if you were listening to this and you've heard the first 2 parts, make sure you subscribe, so if I do any future videos, you'll also be notified. I think you have to press that bell notification. Also remember to like and share it with your friends, because really we are looking to expand the service we're offering so we can help students with GCSEs as well as A-levels. Okay, we've also got a section called The Nature of Reality, where you can watch videos which are not necessarily made by me, but they're there for helping you understand the bigger questions in physics, astrophysics, cosmology, and eventually some philosophy as well. So this is something that's going to grow from this channel. Okay, question 8 is another one to do with motion. This time it's mathematical. Car is moving along a road. A car has an initial velocity of 26. Remember, these are suvat. So suvat, S is distance, U is initial velocity, V is final velocity, A is acceleration, and T is time. Now, really, we should use small s, small u, small v, small a, small t. So this suvat should be written in lowercase. So they've given us the initial velocity, u is 26 meters per second. It then tells us something about the acceleration. So you see, when I'm actively reading, I'm writing down what I need to know mathematically. The car then accelerates, a equals 1.2 meters per second squared, until it reaches a velocity. That means increases. It accelerates, so it increases velocity to a final velocity, v, of 35 meters per second. So I'm using v, u, and a so far. State the acceleration linking acceleration, velocity, change in velocity, and time taken. Well, change velocity is v minus u, final minus initial, v minus u, over time taken, change in velocity over time taken. So you should really do it as a word equation, so you won't have any examiner losing the marks for you, okay? But in symbols, these two are equivalent. But when you're defining something in physics, we usually use word equations to make sure we know, or we can prove to the examiner we know change in velocity is the concept, which is v minus u mathematically, okay? So word equations are definitions. Once you've done that, the calculations can then be used to with the symbols, because obviously that's algebra. So they want you to calculate the time taken using the definition of acceleration. So they want you to work out t. So you put your t, finger on the t. If you know how the triangles work, there's another equation you need to add to your list of equations that you need to remember. I don't believe it's given to you, okay? No, it's not. There is a constant acceleration formula that's given to you, but it's not the one you're using here. It's the v squared equals u squared plus 2as. Okay, so once you put your finger on t, it shows that v minus u is over a. So I've changed the subject to, instead of we don't want to work out acceleration, I like to do this, to change the subject to the equation first. I know maths teachers let you put the numbers in and then muddle through the answers, but this is the best way of doing it. So it's 35 final velocity minus initial velocity, 35 minus 26, divided by the rate of acceleration. So if you divide the change of velocity by the rate of acceleration, change of velocity by the rate of acceleration, you will get the time taken. So it'll take 7.5 seconds to accelerate the car from 26 to 35. So as long as you can do the maths, you'll get your 3 marks, one for putting numbers in, one for changing the subject of the formula so you know you're working out t, and one for the answer as 7.5 seconds. That's the beginning of question 8. Question 8 is then talking about radar, which is going to go into the Doppler effect. Okay, so the radar uses the Doppler effect, which we need to explain in this 4-mark question. Okay, so it's a radar speed gun is used to measure the speed of a moving car. So basically it sends out radio waves with the pulse of radio waves. It then bounces back. It's got a detector inside. So the radar speed gun emits radio waves towards the moving car. The moving car reflects, yeah, the radio waves back to the detector on the gun. So it's got an emitter and a detector. The detected radio waves have a different frequency from the emitted radio waves, and that's because of the Doppler effect, okay, the difference. So it's a perceived difference in frequency, or a measured difference in frequency. To change, this change in frequency, so they're measuring the frequency, it looks like, to measure the speed of the moving car, okay? Explain this change in frequency when the car is moving towards the radar speed gun, okay? So the car is moving towards the gun. So when the car is moving towards the radar speed gun, the frequency is perceived to increase, okay? So the frequency increases. So if you know that, you get 1 mark. So you can either put this at the beginning, yes, or you can put it at the end. So you can, if you're not sure which way it changes, you can just put the frequency changes when the car is moving towards the speed gun, because frequency is not as easy to understand as wavelength. So you'll see. So let's say we say here the frequency changes when this car is moving towards the speed gun. This is due to the Doppler effect. So you get 1 mark for this. You won't get the mark for saying change, but you will get it for saying increase. But wait, bear with me. As the car, I think it's better to put change here if you're confused. As the car behaves as the source of the reflected waves, yes. So it's like you've got the emitter being the gun, and then the car being the second source, a reflection. Okay, it comes back. So as the car and the reflected waves are both, yeah, moving towards a detector, yeah, the wave fronts get bunched together, squashed, and the wave fronts get closer together. So if the wavelength gets closer together, the wavelength decreases. Remember, this is the symbol lambda for wavelength. So I think that's easier to understand. So the car is moving towards the radar, and the gap between the wavefronts appears to be smaller because the source of the reflected waves, the car, is catching up with the waves that are bouncing off it. Okay. So if the wavelength, so the reflected wavelength decreases. If it comes closer together, it shows that the wavelength decreases. There's another mark for analyzing what's going on. And as the speed remains constant, because they're radio waves, the speed of the radio waves haven't changed. They are the speed of radio waves, which is the same as the speed of light. Okay? This means that if the wavelength has decreased and the speed remains constant, this hasn't changed, the wavelength has gone down, then it means to make the velocity stay constant, it means the frequency must go up to compensate for the squashed wavefronts as it's moving towards you. So here you can say the frequency must increase. So here you put change, at the end you put increase, and these two points are related. So you're saying the frequency is going to change, but I'm not sure how. Well, then you can analyze how it's going, okay? Because it's easier for students to understand that the waves get squashed, the wavelength gets shorter as it's moving towards you. If you're moving away from you, the wavelength gets stretched. Okay, so if you find this confusing, you need to go and revise the Doppler effect. Okay, so to learn physics, you don't learn it just because the teacher has covered it in class. You learn it by interacting with the material as often as possible. And I'll put my answers down, so if you want to stop the video, you can. And remember, if you haven't got all the marks for this question, then you may want to go and revise. Okay, that's question 8. Question 9, the teacher investigates the penetrating ability of gamma rays, obviously from a gamma source. This is the teacher's method. Place the gamma source at a distance 25 centimeters from the detector. Okay, so radiation detector would be normally a GM tube, which stands for Geiger-Müller tube. These are the two scientists, Geiger and Müller, who created the Geiger-Müller tube. Place a 1 centimeter thick absorbing material between the source and the detector. Okay, this is the method. So you get your gamma source, you place it somewhere, you put in line with the detector, you then put an absorbing material between them. Okay? Measure the radiation count from the source for a time of 3 seconds. Okay, that's what the teacher is using. Calculate the count rate per second. So if you've done it for 3 seconds, you divide it by 3. Do you think 3 seconds is enough? That's for you to decide. Repeat the measurement 2 more times. Why? To average and get a mean value and then divide by 3. Okay, so you've done it for 3 seconds 3 times. So wouldn't it be better to do it for 10 seconds or a minute even, and then get a better, more reliable data that way? The teacher repeats the method, it says, for different absorbing materials. So what does that mean? The different absorbing materials is the thing that they're investigating, and the thing that you're investigating is called the independent variable. Independent variable. Okay? Now it's not a continuous variable, you just got different types of materials and you're going to compare them. Name a suitable detector, GM tube. If you put GM tube, you'll get the mark. And GM stands for Geiger-Müller. Okay? So then, state the independent variable, absorbing material. Explain why every absorbing material has a thickness of 1 centimeter in this investigation. Well, that's another controlled variable. Thickness is a controlled variable. If you want to control different materials, you've got to have the same thickness to make it valid. Okay, it's because the thickness can also affect the results. So you get 1 mark for any of these points. So you make 2 of these points, you'll get the 2 marks. Okay, so any 2 from these 3. Okay, you want to make sure that your investigation is valid. Okay, suggest one improvement that the teacher could make. So we've already discussed it. Measure the count rate over a longer time. That would be what I would put. That's the main criticism I have of this. The second criticism I have of this is that he should have measured the background radiation in the room, because there's always some background radiation just due to nature, the cosmic rays that are coming through. There's always some background radiation, and you need to remove this from your reading. Okay? So it's like a 0 error. The background radiation level is like a 0 error. If you don't do it, you'll have a systematic error in your data. It'll always be higher than it really reads. Or they will accept some general answer, which I don't think they should, but on the mark scheme they say, or take more repeat readings. Well, he's already doing it 3 times. Okay? 3 times an average is fine, especially if you've got a longer time. So I don't like the fact that they're counting this. So for my students, I would say you should put one of these 2 points. Okay? In fact, it would have been a good 2-mark question. Then they're giving you data for the different absorbing materials, done 3 times, yeah? And this, they've worked out the counts per second, okay? So this is the dependent variable. For the 1 centimeter, they're all 1 centimeter thickness, so that's a controlled variable, and this is the independent variable. So you've done it for all those materials: plastic, copper, wood, aluminium, lead, glass, and stone. Okay, so this is annoying for a teacher to have to plot this bar chart. This is a bar chart is plotted because the independent variable, yeah, is a discrete variable. It's not continuous. You can't gradually change from one material to another. It's discrete. Each one is a different thing. So when it's not something that you can decimalize, you can't decimalize the material, you can't do a line graph, so you draw a bar chart. Okay? So the bar chart is drawn like this. It says draw a bar chart, yes, of the mean count rate. So there's the mean count rate. The mean count rate per second. Okay? You must put the units in. If you've labeled both axes properly, absorbing material, no units for that obviously, and you got the both of them labeled fully, you get 1 mark. If you've got a good scale, going up in a nice round number and using the full size of the graph paper they're giving you and drawn them accurately, so your good scale means 50 basically in this case, because the maximum value you're given is for plastic, which was 235. Okay, so this will be 225, this will be 175, this will be 125, 75 and 25. So you choose something. Usually the scale you use should be going up in 1s, 2s, 5s, 10s or multiple of those numbers. You shouldn't use any other values. 3s, 4s, 6s, 7s and 8s are frowned upon. Okay, so if you've got a good scale you get a mark, and then if you've plotted correctly you'll get the other marks. Okay, and you should plot them all to the nearest half square. So 227 will be in between two squares, 137 between two squares, 202 between two squares, because each little square is a value of 5. The only one that's not is 195 and this one, which is 235. These ones will be exactly on the line. So how accurately you draw it, obviously if you've got a ruler, yes, which you're meant to have in an exam, you draw them to show the bar chart accurately. So how well you've drawn your graph can get you 3 marks. I'm not going to spend more time on that. And that's the second part of this investigation. It then goes on to ask you some questions. Why is it a bar chart that's used? The correct way to display the results, because the absorbing material is not a continuous variable. That's the only answer. So you have to read through that, understand what discrete variables mean. It means it's not continuous. If it's continuous, you would be able to make a line graph. Okay, so if it's both variables are continuous, you use a line graph. If one is discrete, you're trying to just compare different materials, for example, then you use a bar chart. Okay. A student then concludes the plastic is the best absorber. Yeah. So for the before, revise all the variables: continuous variables, discontinuous variables, independent variable, controlled variables, and so on. We've been through them all. Okay. A student concludes the plastic is the best absorber of the gamma radiation. Well, plastic is the one which was the highest in the bar chart. Okay, plastic. Well, highest means most radiation can get through. So it's the best absorber of gamma radiation because plastic gives the largest count rate, mean count rate. Mean means average. Okay. Evaluate the student's conclusion. The student is wrong. Okay. Why? Because the best absorber is the material that lowers the count rate the most. Yeah. Show that you understand what you're talking about. So lead is the best absorber. Yes. So lead was the one which, because lead is very dense, it gets the value down to 97. Okay. Still quite high. Because remember, gamma radiation is quite penetrating. All right, the next question is question 10. So as you get to the end of the exam, the questions become trickier and more detailed. Now, the question is about light. So you have a light ray going in. Okay, it then refracts. You normally draw a normal if you want to measure the angle. I should have drawn it with a ruler and a dotted line. So this is the angle going in. This is the angle of refraction. But we're looking at what happens here. Okay. So remember the normal. So it's entering a glass prism. Okay. And this is air. So for air, the n value is about 1.00. For glass, what is it? It's normally about 1.5. So let's see what they're going to ask us. Describe what happens to the ray, light ray, when it enters the prism at point A. Yeah, so what happens here? Well, by drawing the normal and showing you these angles, the light slows down as it enters the optically denser material, glass. It refracts, in other words. So, and what happens when it refracts? It changes direction, or it